So far in Algebra 2, we've talked about lines which have an x to the first power, and then that's all that's really going on in those. In Chapter 4, we talked about quadratics, and we had x squared plus x plus a constant. So what if we get into things that have higher exponents than just x squared? So that's where we get into polynomials, and that's what we're looking at throughout this chapter. And for an equation to be a polynomial, it has to have real coefficients, so real number coefficients, and then whole number exponents. And we're not concerned about anything outside of that or any other of strange trigonometric or algebraic functions. Just whole number exponents and real number coefficients. So there's a few key terms that we need to look at when talking about polynomials, and those are degree, leading coefficient, and the constant term. And then another thing we need to be able to do is evaluate a polynomial, which just means given some value, can we plug that value in and get what that equation would spit out for us. So the degree of a polynomial is the highest exponent that we have. So what we're looking at here, we have f of x equals 3x cubed plus x squared minus 12x minus 5. And typically, we're going to write the powers in decreasing order from left to right. That's kind of the standard form for polynomials. So the degree is the highest power. So here our degree is 3. This is a third degree polynomial. A quadratic would be a second degree polynomial because the highest power is x squared. An equation that gives us a line would be first degree because we have mx plus b. The highest power is x to the first, so that would be first degree. So the degree, again, is just the highest power. Another term and value that's going to be useful to us is called the leading coefficient. I will abbreviate that as LC. The leading coefficient is the coefficient with the highest power, and so in most cases that's going to be in the front, because if we write it highest power first, lower ones at the end, then our leading coefficient is going to be in the very front of that equation. So here our leading coefficient is 3 because that's the coefficient of our x cubed term. Now if we had put the equation in some other order, we would have to look for that term with the highest power, and 3 would be the leading coefficient. So in some of the problems might try and trick you and reorder things, so you have to look through there to find what the leading coefficient is. Okay. And one other value that might be important to us is the constant term. So the constant term, and that's just the term that doesn't have a variable in it. It's the one that is constant. It's on its own. There's no x. So our constant term here is -5. Okay, so degree is the highest exponent. Leading coefficient is the coefficient of the term with the highest exponent. And the constant is just the one that has no exponent with it. So then the other thing to do is evaluate the polynomial for the given value. So here we're given x equals 2. So let's find f of 2. So we just plug in 2 and crunch that out. And just remember that whenever you see evaluate in any directions, your answer should probably be a number. You're going to have a number as your final answer. So 2 cubed is 8. 3 times 8 gives us 24. 2 squared is 4. Minus 12 times 2, so minus 24. minus 5. If we add those across, the positive and negative 24 cancel each other out. So positive 4 minus 5 looks like that leaves us with negative 1. So when x is 2, f of x is negative 1. So that's the evaluating step. Moving on to the second example, we have g of x equals x cubed minus 5x squared plus 6x plus 1. So very similar to the last one. I guess we should make sure that it is a polynomial first. So are the coefficients real numbers? Well, we have coefficients of 1, negative 5, 6, and 1. So yes, that condition is satisfied. And then do we have whole number exponents? 3, 2, 1. And I guess we could say here that this is kind of really x to the 0, because x to the 0 is 1, and so we would just have 1 times whatever that constant is. So we do have whole number exponents, but we don't really have to include that there, and we can do without. So degree, again, is our highest power. So this is a third degree polynomial, just like the one before. The leading coefficient is the coefficient with that term. So what we really have there is a 1. We just don't have to write it when we have 1 x cubed. And our constant term is that one at the end that does not have a variable attached to it. So our constant is a positive 1. The value we're asked to evaluate for is x equals 4. So we plug in 4 to the function, so 4 cubed minus 5 times 4 squared plus 6 times 4 plus 1. 4 cubed gives us 64. 4 squared is 16 times 5 is an 80. 6 times 4 is 24 plus 1. These two pieces here, 64 minus 80, that'll give us a negative 16. And 24 plus 1 is 25. Add those and it looks like we get a positive 9. And on to our final example. H of x equals 9, x to the 4th minus 5, x to the negative 2nd, plus 4. Do we have real number coefficients? 9, negative 5, and 4. So yes, we do. Do we have whole number exponents? We have exponents of 4, negative 2, and then our constant term. That negative 2 is not a whole number. Whole numbers begin with 0 and then the positive counting numbers. So since we have a non-whole number exponent, this is not a polynomial. And we can stop there. Oh, I guess we should explain why. Why is it not a polynomial? That's because we have a negative exponent. And that's the main thing that you'll probably see this section that would disqualify something from being a polynomial. Because we haven't really talked about many other things that won't be a polynomial, so we're not going to throw in those and try to trick you with things that we haven't talked about yet.